Hello all. Today's lecture is on reflection of light. We'll begin our lecture with the story of light, then we'll move on to the different kinds of image formed by the spherical mirrors, and at the end we'll study about the mirror formula and magnification. Greeks and Arabs gave a theory of light that there are certain probes which come out of our eyes which collect information about the object and comes back to our eyes and gives the information. Arabs said that light directly falls into our eyes. But through a series of experiments in the early 18th century, Isaac Newton gave the particle theory and believed that light are made up of certain particles called corpuscles. But in 19th century, scientists proved particle theory wrong and said that light shows interference pattern and behaves like a wave, and then gave the wave theory. But in 20th century, it was believed that light transfers energy in small and discrete packets called quanta, and quantum mechanics came into picture. But at the end we concluded that light is having a dual nature. But today we'll study about the particle nature of light. Before that, we need to know about the laws of reflection. What are laws of reflection? The angle of incidence is equal to the angle of reflection. The incident ray, the normal at the point of incidence, and the reflected ray, all three lie in the same plane. So whenever light falls on a highly reflecting surface, the light gets reflected. So the mirrors can be of two types, plane or spherical. Images in case of plane mirrors can be virtual in nature, and if it is a flat mirror, the size of the image and the size of the object will be of same size and equidistant from the plane mirror, and the image is upright but laterally inverted. In case of spherical mirror, if this is a sphere, this if this is considered as the reflecting surface, then this is a convex mirror. If this is the mirror and this is the reflecting surface, it is called as a concave mirror, like a cave. So concave and convex. So before drawing the ray diagrams, we need to know certain terminology and certain rules. What are the terminology? If this is a sphere, the center of the sphere is called center of curvature. The radius means the distance of the center of curvature to the pole. This is the pole, this is the center. This distance will be called as the radius of curvature. The line passing through the sphere is called the principal axis. This is the aperture. So in this case, the aperture is small. So in small aperture case, we will consider that the radius of curvature will be twice of focus. Now what is focus? A light which is coming parallel to the principal axis. After reflection, it will pass through a point. That point is called focus. Now we'll move on to the rules. If a ray of light parallel to the principal axis passes through, after reflection passes through the focus. If a ray of light passes through the focus, after reflection it passes parallel. If a ray of light passing through the center of curvature, after reflection it passes through the center of curvature only. And if a light is incidenting at an angle, after reflection it will reflected back to the with the same angle. Using these rules, we'll make the ray diagrams for concave mirror case. If the object is at infinity, consider this object. It is made up of various points. Consider any two rays. After reflection, it will pass through and meet at a point. The image will be formed at that point. So these are various position of the object. If it is at infinity, the image will be at focus. If it is beyond P, the image will be between F and P. If it is at P, the image will be at P. If it is between F and P, the image will be formed beyond P. If the object is at F, the image will be formed at infinity. Means the reflected ray will never meet. If the object is between F and P, the object will be virtual and it will be formed behind mirror. In case of convex mirror, we consider two cases. If the object is at infinity, the image will be formed highly diminished and points at object at focus. If the object is between C and in between C and infinity, some beyond C, the image will be formed between F and C. So based on the ray diagrams and based on the nature, there are certain uses of concave mirrors used in torches, used in shaving mirrors, used by dentists for seeing the enlarged view images, and bigger concave mirrors are used for diverging the concentrating the sunlight and producing heat in solar furnaces. But in convex mirrors, they are used in rear view mirrors in vehicles, used as magnifying glass, used inside buildings and security purposes. Now, to study the mirror formula and magnification, we need to know about the sign convention. It follows the simple new Cartesian sign convention that if this is the principal axis, this is the point where the pole is kept. This is the point which is called the origin. Anything coming to the right is positive, left negative, top positive, negative. This is the sign convention. By using this sign convention, we can study about the formula, mirror formula. If u is the object distance, which is in the left hand side, if it is in the left hand side, it's called as object distance negative, minus u. Whenever we put the value, if the object is kept in the left hand side, we'll simply put it in as a negative. If the image is in the right hand side, v, it is positive. Focal length f. So any two values, we can find the third value. Similarly, magnification. Magnification is the relative ratio of the image size with respect to the object size. So h dash is the height of the image and h is the height of the object. We can find the ratio and find the magnification. And using the values of v and u, we can also find the magnification. A negative sign in the magnification indicates that the image is real, and a positive sign indicates that the image is virtual. In the next lecture, we will study about the refraction of light. Thank you.